Where to begin? I've got the list of questions about what your company is doing and all that, but I would be interested in maybe doing a real quick ricochet of just, and you can of like 5 questions. I'd like you to answer in 1 word or 2, maybe 3 words, but that's it. Biggest benefit of AI? This was not supposed to be that hard.
Well, I find it mainly interesting.
Interesting.
Yeah.
Okay. What's the biggest problem that needs to be overcome?
So for the thing I'm working on, you need to prove that it's good enough.
Okay. Is there an area of AI that it shouldn't be applied to? Is there an area in the world that AI should not be applied to?
Ethics.
Okay, wasn't expecting that. Who is your AI hero? You can't say Nathan.
Isaac Asimov.
Very good. Well, that's great. Foundation. Who is your hero in general?
So that is a question you could have popped me yesterday over the dinner table, because who's my hero in general? So I think Elon Musk is a general example in many ways. There's my PhD supervisor is a hero in many ways.
We only have 80 minutes.
Yeah.
Okay.
Let me think about it. I'll get back to you.
That sounds fine. Yeah, that was not on the list. That just kind of came to me like, well, in general, you're a human being, not just an AI.
So before this, I was thinking this is actually my favorite format because it takes no preparation from my side, but I just see the other edge of this sword.
It turns out I came to this thinking it's going to be very easy, and I'm now sweating and thinking this is not going to be quite as easy as I thought.
Pulling teeth. Yeah.
And let's go into the company.
Okay.
What do you guys do?
So we thought it would be nice if the small electric airplanes that people are building left and right would be as autonomous as we all know cars are going to be. So we thought we'd bring the equivalence of level 5 autonomy to those airplanes. And the reason for that is, so actually I just wanted to do something interesting. And there's a lot of students I'm based in Zurich. The ETH has a couple of groups that produce a lot of literature and students in the fields of robotics and autonomy. So I thought, why don't we do a self-driving car company? And this was around the time when all that happens on Nathan's slide number 3 happened. So everybody is doing self-driving cars. And around that time, I was also introduced to a company called Lilium Aviation. They're in Munich, and they make this James Bond-like vehicle that's an electric plane. And after visiting them, I did the back of the envelope calculations myself, and I thought, so this is totally going to happen. And it's driven by the revolution in your phones, which has driven a revolution in the batteries, which has driven the energy densities of batteries to the point where flying is now feasible. So people are building these things left and right. And then I had some exposure in a previous life to the aerospace industry. I know that volumes are really small, and one of the bottlenecks there is that you need a pilot license to be able to be allowed to fly things through the air. So typical volume, if you're a successful small airplane manufacturer, is 50 planes, then you're really successful. So I thought, when I saw the Lilium, I thought that thing needs to have the pilot license so you don't have to. And then it sort of all fell together. So I went back to the group of students I had assembled to do the car project, and I said, what if we did flying? And then one was, I thought the other thing was crazy, but now I'm out of here. And the other one's like, yeah. So that was about a year ago. So
self-flying cars.
Self-flying cars. And then it's actually very hard to get an airframe airworthy. It's also very expensive. So what we're betting on is that at least 1 or 2 will manage to do that. And we want to be like Mobileye. So we want to make sure that by the time they're ready in 5 to 10 years, we have the autonomy. And so that's about our horizon and our runway, is to get that level of autonomy.
So you say your horizon or runway is 5 to 10 years.
Yeah.
What do you mean by that?
I mean that there's no credible market, or I cannot promise my investors any meaningful revenue within 5 years. And so I've been honest to them up front. Actually, so my angels, I looked deep in the eyes and said, are you sure? Because I'd rather have you as a friend than as an investor. And I'm probably going to lose all your money. but they said, oh, go for it. So I'm doing my
Good
best.
friends to have.
So yes. So you need to build a plane and get it certified for airworthiness. And if you get your experimental on the market by 2017, some are trying, or 18, which is more likely, or 19, which is, then that's already good. But before that's mass produced and stuff. So people are working on that, and it's hard enough. And then so we're trying to skate to where the puck is, and we're specifically targeting this market because the existing planes market is also, it's very small. So like I said, the total volume of single-engine piston-powered airplanes for 2015 was 938. So then you're Garmin and you have the 100% of the market, and you have 938 sales of these cockpits. So it does not justify the kind of investment in autonomy that we're looking at. And on the flip side, if you want, so we need a much bigger market, and we think that these electric VTOLs, they're super cool, but they need full autonomy to be realized. In fact, a month after we started, Uber and Airbus came out both independently with reports on how the bright future is upon us if somebody would please invent this total autonomy. Which sounds easy enough, because we all know these planes already fly themselves these days. Is that going to be your next question?
No, it wasn't actually.
Okay. So because people say that you always bump into people if you try to do something new who say they're already doing that, and they're right up to a point. But if you in automotive, you have these useful levels of autonomy, and you can say, yeah, they can already do that, but can't really do this yet. So in planes, you get a lot of that for free, because when you're in cruise, it's kind of boring. You can nap off, and your autopilot can maintain the level and the heading and stuff, and the altitude, but it's the landing that that's the tricky part. Actually, the art of flying is really only to land when you really want to, and that's a bit of a difference with that's why as a problem it's in a different space than driving. Because with driving, it's not entirely trivial to pull over, but you have a graceful degradation mode, and with flying. That is actually the hard part. So you can't have an emergency program take over and do the landing, because that's actually the main program's task, to only land when you really want to. And what's also interesting is that it has to be super fail-safe. So there's in automotive.
Let me get to the fail-safe in just a moment.
Okay.
In the case of fly-by-wire, the systems they've been developed by a human being, and we know actually how they work. How does AI work in your software? Where do you put the AI components, and what does it actually do?
That is, so there's a lot of regulation in airspace, way more than in cars, and that's for a good reason. It's because flying is really dangerous, because the median, so if you have a small error, the median case is that everybody dies. So these regulations have been put in, and these regulations write down in very great detail how things should be done, and that's actually at odds with the AI and having to prove that things work the right way. And before you're allowed to even put any instrument on board of a plane, you have to prove the extreme robustness and determinism, and that you've followed all kinds of processes to make that. But then these instruments that have been made are fairly basic instruments. They can hold, as I said, so if you go up the cognitive functions, you get into the domain of human judgment calls. What we hope to do is put specific functions in a box and then prove the hell out of how they do better than the human. So the basis has to be good. It has to be done on hardware that is super robust, and that the software does not run out of memory or out of stack or whatever. But when you get to human judgment calls on, can I land here, or is the weather going to look right in that direction, then what we want to do is put these specific functions in a box and just have enough data and simulation to prove that you would be mad not to trust this device.
Okay.
That's the general strategy.
Now, another business person might look at the market and say, gee, this is really interesting, and this is where the puck is going. But to get there, I don't want to build software in that domain. I'd actually like to learn in an area where I can fail fast and break things. Can't do that with self-flying vehicles. Delivery drones.
Yes.
You can jostle it around,
Yes.
and if something happens,
Yes.
someone doesn't die.
This makes total sense. And so the thing is, that's definitely an area where we want to gather data and experience. And we actually thought it was going to be a mandatory detour before we got to put anything in a plane with people. But turns out a lot of the potential customers are actually already interested and willing to let us experiment with onboard devices. But we originally started by making some software devoted to drones. The problem is that the thing we're trying to build is actually going to be slightly over-engineered, so it's not really a market. It's for engineering validation, it would be brilliant. But to have this level of autonomy and fail safety for something that is going to deliver a 15-kilogram package is tricky. By the time your drone gets bigger and more dangerous, rules again currently say it has to be a human in the loop. So then it actually becomes the same case again. The market is slightly bigger then, but also that's currently in motion. It's underdeveloped and growing, and it's a bit ahead of the personal transport one, but not as far as you think. So,
to create the explainability that you need to show the regulators and the industry
yeah.
why AI makes the decision that it does, do you have to sacrifice performance?
We don't know yet. We're experimenting with it. We do have to invest in figuring out why it works. So, which is intellectually a very stimulating activity, which is why I hope to attract the best and brightest to come and work for us. So it's not just how it works and that it works, in different order, that it works and how it works, but also why it works so that you can explain this. So there's a couple of things. There's been some cool stuff with running things in reverse and seeing what the thing dreams. We hope to leverage some of that to prove that it would never do this unless you present it with this input, which of course never happens. You could also have more classically engineered monitoring systems running side by side that says, yeah, now it's actually going crazy. We'll fall back to this other thing. So there's a couple of options to explore. We just started, so which is also why I'm grateful for this format, because if I had to do a demo, but we'll get there. A year from now, we'll have a demo. Okay. I digressed.
It's okay. My last question to you before I open it up to others.
Oh.
Get your questions ready. Has anyone told you who Daedalus is? Yeah. Because his first user, it didn't end well for him.
Yeah, I was expecting you to start with that. We got a lot of comments on it.
Yeah, of course. Nothing's original.
So had we been targeting consumers, and if our success depended on hundreds of millions of users downloading an app, we would have probably changed the name by now. So if classical education these days, I don't know what it is, but he was also seen as the prototypical inventor in the Renaissance, and there's a whole story to how you should be careful with the sort of stuff you invent for all kinds of moral reasons. For example, he also invented this labyrinth with the Minotaur in it, and then became its own victim. And so let this be a warning to all of us inventing labyrinths. Also, I mean, to be fair, Honda came out with a car called the Odyssey, and nobody thought, okay, that's a car that takes you on a 10-year detour, everybody dies, and when you come home, somebody's sleeping with your wife. So now we have chosen the wrong name. I don't think so. Sorry. Yeah.
Okay. Pliny, in his histories
yes.
Of ancient Greece, points out that they looked upon this master craftsman of Daedalus and said, his work looks uncouth, but it clearly has been touched by divine inspiration. So you can have it both ways.
He got some wings from a goddess, so it's...
we made his wings.
Yeah.
Athena may have helped him, sort of nudged it along. Opening it up to questions on Athena, on Spartacus, on Daedalean, on deadly things.
Daedalean, we like.
Daedalean, sorry. That's how they pronounce it in Denmark.
Yes, of course.
But,
and actually, my co-founder and I pronounce it different. So maybe we should. It's now too late. We're on the air. People at home have seen it. We cannot change this name again. So.
Okay, good. Okay, great. Questions?
Okay, cool.
Yeah.
Hi, I'm Stanley from UCL. So you used the phrase level 5 autonomy. Could you just expand on that and what that means?
So these are the levels defined in the automotive industry, where level 5 is brains off. You just get in your car and say, I would like to get to the other side of the city, and it is as if there's a human driver. So our co-founder Anna is actually a pilot, and she's gone through the requirements for the exam for a commercial pilot license. And that's our product roadmap. So these are all the things you have to do as a human when you step in a helicopter and say, I would like to get to Munich now. And somebody has to check the weather and the NOTARs and the METARs and check that you don't cross airspaces that aren't allowed to be crossed. And you as a passengers know nothing about flying, but you enjoy the view, and actually you get a chit-chat about the weather and what interesting things happened yesterday on this flight from the pilot. So these are all functions we have to cover. And in cars, it's called level 5. And level 0 is there's nothing. Level 1 is you have cruise control. And then, so Teslas are around level 3, 4. Elon has promised level 5 by end of next year. I don't know what the promise is now. And they'll get there, maybe not on that schedule, but for cars, it's clear that in 10 years, you put your 4-year-old in the car and tell it to drive to school, at least in LA, where you drive to school. And so that's the level we think you need. So if you imagine that there's 50,000 of these Liliums and Volocopters and Z-Aeros sold, and they're crowding the skies, and it's all by people communicating over a very noisy radio with air traffic control over the city of London. That's going to be a complete and utter disaster. So it's in the interest of everyone that this is done to the level of standards that you have today, but not by humans.
Luuk, when am I going to put my 4-year-old, 6-year-old into a self-flying car and fly him to or her to school?
So I think that 5 to 10 years is a reasonable.
5 to 10 years is for the cars, and the cars an easier.
No, I think the cars is 2 to 3 really.
No way.
Yeah.
No way. We're gonna hold a second.
Well,
Poll. Show of hands. Who thinks we're going to be putting kids into cars? We're going to have level 5 autonomy in vehicles in 2 to 3 years. We don't even have the regulatory apparatus for it. So raise your hand. Okay, I see basically 6.1% of you.
Yeah. Okay.
And who
You're
here,
very data driven. That's yeah.
you got to own it. Got to own the problem.
Yeah.
So who thinks that I'm going to give you? You've got buckets. You've got 10. I'm going to actually 5, 10, 20, 30. Self-flying cars, mainstream, that you put your kid in and it takes the kid to school in 5 years. No, of course, in 10 years.
Yeah.
Okay, there's a few hands, maybe like, 5%. In 20 years. 25 plus, raise your hand. Okay, so the majority was basically 20 years.
So I'm of course the self-selected audience, because if I thought it was 20, I would do something else now. I wouldn't be sitting here telling you I would be doing this. But
you're not collecting, like Bayesian inference would suggest you'd collect more information and you'd adjust your.
No, because at some point you give up because everybody says, "No, I can't." And the one group of people says they're already doing that, and there's the other group of people says, "I can't be done. It's 50 years out." Yeah, we'll see.
We'll see. That's
and
great.
also, it's not a reason not to try.
Totally great. I'm sure there's lots of questions. Here's what we're going to do because we're running out of time. We'll take as many questions as we can all at once, and then we'll throw it back to Luuk for a final comment. Sounds reasonable. Go for it. But there's a mic. We'll do it in the order that the hand is to the mic, so that way it'll be easier for the people with the mics.
Hi, I'm Gabriele from the University of Oxford. And I'd like to ask something which is a bit transversal to self-driving cars, self-flying cars. I mean, of course, there's a discussion about responsibility in case of failures going on. Mm-hmm. And I'd like to ask where this discussion is going, which is the main direction.
So I think it's...
Oh, don't answer. We're going to collect all the questions so that people have a chance to give an observation or a thought, and then you get to sum up at the end.
Okay.
Arthur from King's. The one problem I'm having with self-flying cars is at what level will they be flying? So are they going to be like city level? Are they going to be 300, 400, 500 a kilometer above the city?
Great. Altitude. Next, other questions, or observations? Yeah.
Sounds all great. What are you specifically doing those months?
Yes, coding. Yes. We write code.
You're allowed these one-word answers. Coding. Altitude.
Hello, my name is Alexei from University of Southampton. How do you convince legislators to let people without pilots' licenses to be in planes above cities?
Yeah, that is the hard one. That's actually...
Regulatory. Simplicity, guys, simplicity. Question. Microphone.
Hi, I'm Jessica from Cambridge. So you said some of your customers are already letting you use your systems on board. Like your
Willing to, we're in talks to, they seem
Okay.
willing to let us experiment.
Qualification.
So like how, could you tell us more about how you're training and building your models?
After I answered all the other questions.
Any other questions, or is that it?
Sorry, Duncan McInnes from Bank of America. How dependent are you on hardware and sensor development, or is the current industry sufficiently robust in terms of what you can actually measure?
I'm going to need to take notes now, because these are all very good questions.
Great questions. Go for it. Now the questions are over. We entreat you to respond.
So I forgot the first one. I tried to keep them. Let's do it in reverse order. So hardware. Yes, it's the hardware that's consumer level is good enough now, but you need to prove that it meets the hardware standards of aviation, which means you have to be able to shake it really well, make it really hot, and still work. So there's a lot of these new NVIDIA chips would be great if somebody would take them through airworthiness certification, and it's probably a matter of throwing money at it. But we don't need new Nobel Prize winning hardware inventions. It should fly high enough to not bump into buildings or your face. Convincing the industry that you are allowed to do this. So we had this. Actually, this idea came to me in 2013 when I moved to Los Angeles, and I was forced to take a driver's exam because Swiss driver's license can't be trusted in California. And it's a grumpy guy that sits next to you and tells you to drive around the block. And I realized with the state I knew the Google Car project to be in back then, if somebody would bother to add voice interaction, it could totally pass that test. So our goal here is we want to make an autopilot that just passes the exam for human pilots. So we don't want special rules. We don't want special air lanes that our drones are allowed to fly in, or our eVTOLs are allowed to fly in with special rules. Because special rules introduced in civil aviation happens almost never. So we think if we can make the case, this is everything your human pilot does. And only we fail the medical because we don't have a heartbeat. But other than that, we have everything. Then you can make a good argument. So that's the goal we're going to set, and then we're going to chum up with all the regulators and show them that we're doing this in their interest, and then we hope for the best. There was another very good question.
There was two really good questions. One.
They were all very good questions.
Exactly.
They were all my favorite question, but there's two.
And then there was, why would they just shout out what it was?
Oh yes, I think that's a red herring. It's the trolley problem, academic. What if we have a bucket full of babies and we have a dragon and they're all going to collide? So there are already insurers that give you a lower premium if you have your Tesla on autopilot, because in the long run it's going to statistically save everyone. So it's going to be a matter of public health to take humans out of the loop. So you have a meatball with a control loop of 200 to 400 milliseconds. It's really unreliable, especially when there are surprises. It's going to be fairly easy to demonstrate that it would be better for all of us if driver's license were this thing. It's like, riding a horse. You just do it for your own amusement, but don't make society depending on everybody being craftful horsemen.
Luuk, from one meatball to another, thank you very much. This was fascinating. Yeah.
That was fun.
That was a lot of fun. Great. Thank you.
All right. Fantastic show, guys.